All right, Chapter 7, which would be corrosion rate determination. We're just reading in piping inspection code, inspection repair alteration re-rating Inservice piping system ABI 570, second edition, October 1998. I believe we're on 24. Not, well, all right. 7, corrosion rate determinations. Remaining life's calculation. Remaining life of the piping should be calculated the following formula. Remaining life years equal to actual minus the T minimum corrosion rate with the inches of the millimeters per year with the actual minimum thickness of the inches determined with the time of the inspection specified in 5.6. T minimum, the minimum thickness of the inches of the millimeter for limiting section zone. Long-term corrosion rate with the piping surface shall be calculated with the following formula. Corrosion rates LT, time on list of the time years between the last inspection. Short-term ST corrosion rates over the piping circuit calculated with the following formula. Corrosion rate ST equals T previous times T last time year between the last and previous inspection. Long-term and short-term corrosion should be compared to see the results over the scheduled remaining life. See inspection 6.3 with the inspection interval determination. 612, the newly installed piping for the service, the new piping for the service condition of the being changed. One of the following methods of the employed will determine profitable rate of the corrosion with the remaining wall thickness at the time of the new inspection is estimated. Corrosion rate of the piping surface must be calculated with the data collected with the owner and user of the piping system of similar material with the comparable surface. If the data same similar surface is not available, the corrosion rate of the piping surface may be established for the owner and user experience with the published data with the piping surface of the comparable surface. If the probable corrosion rate cannot be determined with either method listed within item A and B with the initial thickness measurement, the determination should be made no more than 3 months of the surface using non-instructional thickness measurement of the piping test system. The corrosion monitoring devices such as corrosion coupons and corrosion probes may be used with the establishing timing of the thickness measurement. The subsequent measurements shall be made in appropriate intervals of the corrosion rate established. 713, existing pipes with the corrosion rate which should be calculated either with a short-term, long-term base with the term short-term calculation reading with the two most recent inspections should be used with the long-term calculation thickness for the most recent initial and nominal inspection should be used with the most with the higher than the two rate should be used with the estimated remaining life and say at the next inspection interval. If the calculation indicated that the inaccurate rate corrosion has been assumed, the rate should be used the next period adjusting the agree with the actual rate found. 72. Maximal allowing workable working pressure determination. Maximal allowable working pressure for containing even the piping system should be established using the applicable code. Computations made from the known material. The following essential damage details are known to comply with the principle of applicable code. Upper and lower temperature limits of specific materials, quality, material workmanship, inspection requirements, reinforcement openings, and electrical requirements. For unknown material computations made by the assuming lowest grade of the material load joint efficiency of the applicable code, maximal allowable working pressure recalculated with wall thickness for the computation shall actual thickness determined with the inspection C5.6 for the definition, minus twice for the estimated corrosion loss for the day of the inspection for C6.3. The allowances should be made with the other loadings in accordance with the applicable code. Applicable code allowance pressure and temperature variation, maximal allowable working pressure permitted over all the associated code criteria specified. Tables 7.1 contain two examples of maximal working pressure illustrating use of the corrosion half-life concept. Table 171 examine ample calculation maximal working pressure illustrates using corrosion half-life concept. Example, the description temperature 500 psi gauge of 400 degrees Fahrenheit pipe description nominal pipe size 16 standard weight A106B outside diameter of the pipe 16 inches allowable stress 20,000 psi longitudinal weight well efficiency E1.0 thickness determined for the inspection 32,000 hundredths of an inch. Corrected corrosion rate 1,000 of an inch per year. Next plan inspection 5 years. Estimated corrosion loss date by the inspection 5 times 100 times 5,000 of an inch times 5 times 254,000 of an inch minus 1.27 millimeters. All right, maximum wall working pressure in the U.S. units 2 times SETD 550 psi system and institute units 345 kilopascals collusion. Okay. Example: the next plan inspection 7 years estimated corrosion later date. Expect new next inspection 7 times 100 equals 7 hundredths of an inch. 7 times 254 thousandths. That's in millimeters. Maximum allowable President unit US instruments 2 times SE times D 450 psi gauge system instrument units 3,104 kilopascals. Conclusion must reduce the inspection interval to determine the normal operating pressure will not exceed the new maximum working pressure during the 7th year renewal of the piping before the 7th year. No PSI gauge pound per square inch, gauge PSI pounds per square inch. Formula maximum pressure ASME B31.3 with equation 3b, where T is corroded thickness. Alright, 7.3, minimum required thickness determination. Minimum required pipe wall thickness. Retirement thickness shall be based on pressure, mechanical, structural consideration, property design formula, and code allowable stress consideration, both with analyzed localized control. It should include for service with a high potential consequence failure where intent may occur with a piping engineer shall consider increase the required minimum thickness with a calculated minimum thickness provided unanticipated unloading, undiscovered metal loss resistance, normal abuse. Alright, 7.4, evaluation of local thin areas. Locally thin areas may be developed with a piping engineer using the following methods in conform with the latest edition ASME P31G. Detailed numerical stress analysis of the finite eliminated analysis area to determine the adequacy, continuous surface. The result of the analysis should be evaluated to describe ASME boiler pressure vessel code section 8 with the division 2 appendix 4 with the article 4.1. Maximum allowable stress of the applicable code should be used in place of the SM division and no class of the allowable stress used the evaluation greater than 2/3 of the system specified minimum yield strength at the temperature design temperature of the creep of the range material in accordance. Additional consideration beyond the scope of division 2 is necessary. Such effects for the creep fatigue interaction. Independent calculation appropriate weld joint factor for the longitudinal weld with having a joint factor less than 1.0 corrode as well. The surface remote from the weld of the calculation must be in the determine the thickness of the weld. Remote of the weld governs allow the working pressure for the purpose of the calculations for the weld includes one to the parent metal of each of either side of the weld with twice the metal minimum measure thickness either side of the weld, whatever is greater. Alternately, the weld joint factor may be increased. Radiographic examination conforms with the principles of ASME B31.3 with corroded area of the pipe cap may be avoided, elevated in accordance with the paragraph 5.7 items H American Petroleum Institute 510. Alright, 7.5, piping stress analysis. Piping must be supported with the guided A's, its weight with carried safely with the B, this position, flexibility, thermal expansion, contraction. C does not vibrate excessively. Piping flexibility is increasing with the concern of large diameter piping greater the difference between ambient and operating temperature conditions. Piping stress analysis for the system flexibility support adequately normally performed as part of the piping inspection. There are many existing pipings if they analyze the part of the original design as part of the pre-treating modification results. Analysis can be useful for the developing inspection plan with the uninspected movement of the piping system is observed. This is during external visual inspection. The inspector should discuss these observations with the piping engineer evaluate the need for the conducting pipe stress analysis. Piping stress analysis can identify the most highly stressed component of the piping system to predict with the thermal movement of the system placed in the operation information can be used to concentrate inspection efforts at the location most prone with the fatigue, with the damage of the thermal expansion heat, and the cool down cycle with the creep of the damage of the high temperature pipe with the corroded predicted thermal movements of the observed movements can help identify the occurrence of the uninspected of the operation conditions, deterioration of the guides and support, consolation from the piping engineer may be necessary for the example to determine observe the deviation of the analysis prediction, in particular with complicated system involved with a multiple support guide between the endpoints. Piping stress analysis may be employed with a help solve the observed piping vibration program, the natural frequency of the piping system will vibrate, predict the analysis, effective additional guiding of the evaluated assess the ability of the control of the vibration, creep of the system, natural frequency beyond the frequency of the existing forces, such as machine rotational speed, is important to determine the guide of the add of the control vibration do not adversely reflect, restrict thermal expansion. Alright, 7.6, reporting records of the piping system inspection. Significant increase of the corrosion rates should be reported with the owner and the appropriate action from the owner and that shall maintain appropriate per minute progress of the record of each of the piping system cover the API 570 of the record shall contain permanent data of each of the piping system service the classification, identification number, the inspection interval, the document necessary to record the name of the individual form performing the testing and the date of the time of the test, result of the thickness measurement, other type of the inspection repair with a temporary permanent alteration, re-rating the design information. Piping drawings may include information for the maintenance activity of the affecting piping system. Integrity should also be included. The date and the result of the required external inspection should be recorded. API recommended practice 574 with the guidance of piping inspection records. The use of computer-based systems storing, calculating, and analyzing data should be considered in view of the volume of the data of the generated of the piping test program. Computer programs particularly useful for the following: store over the actual thickness rating, calculating short or long-term corrosion rate, repeat time and date, marks allowable work, pressure reinspection intervals with a test point by test point basis, highlight areas high corrosion rates, circuits overdue with the inspection, circuits closed with the requirement thickness, other information, algorithm for analysis of the data with the entire circuit that also may be included with the program. Care should be taken to ensure the statistical treatment of the circuit data result of the predictions accurately reflect with the actual condition of the piping circuit. Chapter 8, repairs, alteration, re-rating of the piping system. Testing.